The final part of this lecture on Chapter 1 deals with strength and range of motion. And so reviews on using strength data and then reviews on the names of different postures. So starting out looking at strength data, I'm going to refer you to page 66, which is table 1.13. This table contains maximum power grip strengths of men and women. And power grip strengths, if you recall, we used a dynamometer, so a hand dynamometer or power grip dynamometer to measure grip strengths. We're going to be looking at the effects of posture, so different wrist hand postures, different tool sizes, and use of different types of gloves and how they affect your grip strength. So table 1.13 on page 66, again looking at the layout, becoming familiar with that, it presents a number of studies. The top of the table contains information on males, and so there are a number of males that have been measured. You'll see that the number of pupils in the first column, the first study looked at 463 people. The population that they looked at was industrial applicants, so people working, males working in industry. It refers to males only. The age range, it tells you how old they are so that you can match their age range tested to your population in your workplace. The strength in newtons, and we're going to not look at the metric. Instead, we're going to look at strength in pounds. Some of them give you an average, plus or minus. Some just give you the average. And then the references, if you wanted to go back and check and look further into that particular study, it tells you where the data came from. Okay, so that's the basic setup. The basic setup. Whenever it switches from males to females, they're going to give you a total at the bottom. Compiling all these studies together, they looked at 1,047 males. The males had an average grip strength in pounds of 110 pounds of force. Similarly for the females, overall across all the studies they looked at, the bottom of the female area tells you that they looked at 621 females, and their average strength in pounds was 62 pounds of force. Okay, so we're going to be working with these averages. Wanted to show you where they came from first, though. Okay, so I've copied that over. Okay, whenever they collect grip strength, they typically test under ideal conditions, meaning that they're going to be using, if you had to, where are you stronger, using gloves or doing it barehanded? And your answer is typically barehanded, you're stronger. Gloves cause your hand to slip, slide, you can't get a good grip, they affect your grip size and so on. And so typically barehanded, you're stronger. Ideal conditions for the size of grip, could you imagine that your grip span is too small, just right, or too large? And just like the three bears, the just right in the middle, you're stronger, if the size is correct. And then looking at your wrist posture, the reason why we want you to work in a neutral versus a deviated posture is because you're stronger in neutral. You tire out more quickly. In deviated, you're not as strong, and so the ideal is neutral. Okay, so testing conditions are barehanded, just right size, about 2 inches, and then neutral posture. And so anytime we apply this data that males can squeeze or grip 110 pounds of force, females can grip 62 pounds, we might have to adjust this for the conditions that are actually present in our workplaces. And so we're looking at using, again, those averages when conditions are not ideal. Just like we did with anthropometry, body size, if we have a strength, we typically try to design for, ideally we try to design for the weaker person. So out of males have a grip strength of 110 pounds, female 62 pounds. We can see that given a preference, allowance for that, given an ideal situation, we would try to design for the females. If they can do it, then the males will also be able to. And so starting out with the 62 pounds of force that females can grip, we would look at page 67, which is table 1.14. That gives you the adjustments for non-ideal conditions. For example, it's going to give you the percent of your maximum grip strength that remains if you have these non-ideal conditions. And so 25% radial deviation, you go down that table, the first line down, it'll tell you that reduces your grip strength down to 80% of your strength. So if you're at 25 degrees of radial deviation, you're bending your thumb. So you're bending your wrist so your thumb moves closer to your forearm. So if you're in that posture, you've reduced your grip strength down to 80% of your maximum strength. And so if a female's grip strength is 62 pounds of force, we would multiply that by 80%, so 0.82 or 0.80 times our 62 pounds under ideal conditions, and we would come up with she still has a grip force left of 49.6 pounds. Okay, so if a worker is working in 25 degrees of radial deviation, then her grip strength, her allowable grip strength, her maximum grip strength we could expect her to use on the job would be 49.6 pounds. Second question, well, what if instead of the deviation, now we have a grip size, instead of an ideal grip size, instead of the tool being 2 inches, so having a grip span of 2 inches, now it's only 1 inch. It's too small. You can't, again, exert your full force if the grip is too small for you. And so still we have that 62 pound maximum grip that the average female can do. Now we want to multiply by you can think of this as a correction factor for 1 inch tools. We go down our 1, 2, 3, 4, 5, 6. Our sixth line is 1 inch. It tells you you've got 40% of your strength. And so we're going to multiply the 62 by 0.40, and that will give you a grip strength of 24.8 pounds. Okay, so notice she no longer has 62 pounds available. Now in this condition, since it's a non-ideal, she can only squeeze 24.8 pounds. And then lastly, my last example here, what if she's wearing gardening gloves? Okay, so gardening gloves, they don't fit your hand tightly, they shift around, they're usually cotton, so they don't allow you to have your best grip strength. Going down this same table 1.14, you can see that it reduces your strength down to 74% of your maximum, and so 74% would be how much that still remains. And so you do your 0.74 times your same 62 pound max. That'll equal 45.9 pounds. Okay, so that takes care of grip strength. Pretty quick and easy to use. I guess the most important thing is to remember that you're looking at the strength remaining. So that table is the strength remaining. And then finally, I just simply want you to review the names of the postures. In the undergrad class, we were looking at postures of the wrist. We had radial deviation, ulnar deviation, flexion, extension. So I want you to review those directions. For the posture of the forearm, if you're twisting your hand from a starting position is neutral. That's a handshake position. If you twist your hand so that your palm is facing downwards, you're in pronation. If it's facing up towards the sky, the palm is up towards the sky, you're in supination. So I want you to familiarize yourselves with those. And then lastly, or not lastly, but also you'll be looking at different body parts, but one thing would be your shoulder. Moving your shoulder away from your body will be abduction. Moving it towards and across your body is adduction. Okay. Moving it in front of your body is flexion. So moving it in front, moving it behind your body is extension. And so just go through those to refamiliarize yourselves with the names of postures. Okay. That ends the lectures based on Chapter 1. You should be working on the homework number 1 problems. I've tried to provide you a wide variety of problems so that we start out with some easy ones, some conversions, some percentiles to work your way up to some full-blown problems. And so if you need the extra practice, feel free to start from the very beginning and work through. If some of those basic concepts, it's like, oh yeah, I remember that exactly, then jump to the problems that you need practice with. I've provided answer keys. I have 2 types of answer keys. One have the basic answers so that if you're working through, you've got numbers, you've got all your problems answered, you can just simply go in and check, I've got it right, got it right, oops, missed that one, I want to take a look at it. So I've got those. If you don't know where to start on a problem, I've got full solutions, kind of a step by step through one problem, a step by step through the next problem. And so if there's some problem you're not sure how to get started, or you've checked your answer, you've redone it, you're still not getting it right, you can check the full solutions. Okay, so those both types are posted in Canvas. Again, quick refresher on the anthropometric data, use non-parenthesis data. That's what I've based my answers on. Okay, so use non-parenthesis if possible. Reminder, homework is not collected and not graded. It's there for you to practice. You're practicing to learn it for the quiz. Okay, so your grade actually depends on the quiz in this chapter, and in all future chapters, your grade depends on the quiz and depends on the application that you're producing. Okay, so you have an application applying anthropometry to your workplace. Okay, so homework, work through. If you need help with it, reach out. If you get stuck on something, reach out, but realize the homework is not graded. And then you want to take the quiz and file the application by the deadline. Good luck with your first chapter. Hope to hear from you soon.